All right, so just a quick announcement. Um, Dr. Henry told me that the sign-up sheet for your presentations will be up on Thursday. So when it goes live, you and your group will decide on a specific time to present your group project. How are those coming out? Have you guys started, or are you guys close to finishing, or somewhere in the middle? So just a reminder that, yeah, somewhere in the middle. The group is just a parody video. He also wants you to fill out a page with, I think, 2,000 words around there, and then a presentation slide. And the presentation itself should be like around 20 minutes with like 5 minutes of questions. Uh, but yeah, that's it as far as announcements. So let's do today's lab. So today's is chemical reactions. We're finally doing it. I know it's been pushed back a few times, but um, it's here finally, yay. So I hope you guys did exploration already, um, considering it's a semi-long lab. And I meant to click this. I hope you guys have your materials out and ready for the lab itself. Okay, so let's get started. So first order of business, safety. So let's give ourselves a minute to put on gloves and our glasses. All right. So I guess I should have said this in the beginning, but we are working with like chemicals, so make sure you're in a spot where they're out of reach from like people. It says measure 1/4 teaspoon of table salt and 1 tablespoon of distilled water to a small cup or bowl. Stir to dissolve. And then we're going to measure and pour 1 tablespoon of vinegar into the bathroom tissue. Dampen it entirely and let it stand for 5 minutes. Hmm. Okay. So you should be supplied with vinegar. We're doing the chemical reactions bag, and I believe the biggest bottle there is vinegar. And the only thing we need is the table salt. So, and I forgot it. So I'll be back. I'm gonna grab the salt. All right. Salt at hand and water into a small cup or bowl and stir to the salt. So I hope you guys have like measuring spoons. Um, I'm Mexican, so we don't have that. We usually just eyeball everything. But I think I know what 1/4 looks like, right? That's dissolved, and now we're gonna pour a tablespoon of vinegar onto the bathroom tissue and let it stand for 5 minutes. Oh darn. I forget how bad vinegar smells. So I'm assuming you need to get the area that has the tinfoil. So yeah, that smells. That's great. So let it dampen and wait 5 minutes. Right. While that dampens, I'm gonna read ahead a little bit. So it says rinse the foil with tap water and place on a smooth surface, such as a kitchen counter. Um, use a paper towel to gently blot away water that remains on the foil. As you are drying the foil, use the paper towel to press the foil out, removing any wrinkles or creases. And then flip over the foil and repeat the process until it's completely dry. And then list the 4 reactants that will be applied to the strip of foil with permanent marker. To label the 4 sections of foil shown in figure 4. Fun. Okay. I know there is a section where it's gonna take 3 hours. So um if we run out of time, that's gonna be data that you'll have to do on your own. So 3 more minutes until we wash off the foil. All right, I'm back. I look like a normal person washing tin foil in the sink, and I'm clearly doing the process of smoothing out the tin foil with the paper towel. And I got it as smooth as I can. It's not perfect, but oh well. So where is everyone right now in the lab? Are you guys working at my pace? Are you guys up ahead? Okay, my pace. Okay, cool. All right. So now it's time to write down the reactants on the foil. Amish, Adam, and Franz. Oh, it's all 3 of you guys. What about you, Mari? Where are you currently?
I'm going the same pace.
Okay. All right. Now we're at step 10. Saturate a paper towel with the salt mixture that we did earlier and wipe the labeled aluminum foil until it's damp. All right. That seems damp enough. The salt solution will make the aluminum more reactive. All right. Next step. Uh, okay, so this is a little different. So in the lab, it's saying to use scissors to cut the tip of the silver nitrate pipette and place 2 drops of silver nitrate onto the aluminum foil. Um, so in this lab, the way they did is we don't have pipettes. They're all in bottles. We don't really have to cut anything, at least so far. But I will say because they are in bottles, we are just gonna have to be a lot more careful to prevent spillage. Okay, so the silver nitrate's in a dropper bottle, so that's gonna help a lot more. So let's see. 2 drops of silver nitrate onto the foil on the space directly above the silver nitrate label. And then immediately make observations about the solution and the aluminum foil and record them on data table 1. Okay, so all right, so I did the 2 drops. Uh, it looks like liquid, all right. Those are my initial impressions. And then allow the reaction to proceed for 5 minutes. And it says up ahead, while the reaction is proceeding for 5 minutes, set up the same reaction for the remaining 3 chemicals in data table 1. The following 5 steps are to be performed for all the 3 remaining chemicals. the steps are written for silver nitrate, but should be performed in tandem for all four chemicals. So we have silver nitrate, and then we need to use the copper sulfate, and then calcium chloride, and lead nitrate. So let's write the initial. So the initial was the chemical itself is clear, and when it hit the foil, it's still pretty clear. Wait, that's not. I wouldn't say it's bubbly, at least not for mine. Start time was a few minutes ago. All right, so while that one's cooking, I'm gonna go ahead and drop the copper 2 sulfate in its proper foil location. So since the copper sulfate, uh, it's not a dropper, be very careful when pouring it onto the foil. Damn it. Okay. I put more than 2 drops. That's fine. I didn't spill it on my desk. So initial appearance chemical, blue. I would say slightly bubbly. And it's losing its color. I'm assuming it wants the actual time for this section. I think 5 minutes have passed for the silver. It says, I would say, it says avoid conclusions such as nothing happened. So nothing did happen, but we don't want to write that. So I'm gonna put fade colorless. That works. All right. So for you guys in 3 hours, um, we'll be out of lab. So I would say just set a reminder from 3 hours from now to check back on your solutions. So you can put in the data under 3 hours. So I'm gonna move on to calcium chloride. Damn, I hate these bottles. a 140. Oops. And then uh for me, the calcium chloride is kind of similar to the silver nitrate. It's just clear and colorless solution. And then gonna work my way to the lead nitrate. Mm, I hate pouring these things. Okay, 141 for this one. Yeah. And then also colorless and clear on the tinfoil. So now we can come back to the copper sulfate and it looks different. Nice. It looks burnt. I don't know if that's supposed to. That's fine. Mine turned purple. And I don't know about you guys, but there's like these little dots inside the solution. But I'm assuming those are the bubbles. They kind of look like burnt bubbles. Okay, nice. Something similar happened. Hi, Layla. Uh, just a reminder that we're doing chemical reactions in the lab. So, coming up on 5 minutes for the calcium. Hmm. So if I shine my light on the solutions, the copper kind of looks red, I mean, and the silver actually has like hints of blue that are starting to form. So I expect it to be completely different in 3 hours. So, but the calcium still clear and colorless. So one thing to note is that for my lead nitrate, the solution actually got on the marker writing itself. So hopefully that doesn't uh, intervene with the observations, but we'll see. But for now, it's still clear and colorless. Okay. So after 3 hours have passed, make observations on your solutions and record the data. Over a sink, gently rinse the foil with tap water to remove any residue from the solution. And leave the foil to just dry on its own. And after it's done drying on its own, we're gonna record the data on this last section. Appearance of foil after rinsing. And in terms of cleanup, recycle the foil and retain all chemicals for use in exercise 2. So we have a couple questions, or a lot of questions here. Let's go over them. Which of the reactants in data table 1 showed evidence of a chemical reaction with the foil? So of the 4, which one underwent a chemical reaction? Pretty self-explanatory. And then question 2, list the metals found in each of the 4 reactants in data table 1. Indicate the metal or metals that are more active than aluminum. So here's aluminum. I can't really highlight. Wait, I have a pencil. I'm such a genius. So here's aluminum. And your job is to see which of the metals we were working with in each of the 4 solutions. And it's your job to indicate of the 4, which are more active than aluminum. So on the arrow here, it lets us know any metal above aluminum is more active than aluminum. If it's under aluminum, it's going to be less active. So for this first one, silver nitrate, please excuse my mouse writing. What's the metal in this solution? And then find it on this chart. And if it's more active than aluminum, it'll go on the answer bank. If it's not, then it won't be. All right, next question. Use the activity series to determine whether aluminum would replace the metals in the compound listed in data table 1. Does the activity series ability to predict whether or not a reaction will occur agree with your observations? So if aluminum, where is it? Here it is. It's right here. And we find metals below it, then I believe that means that aluminum in that reaction will be replacing the metal within the solution. So that's the first part. So of the 4 solutions, which one is aluminum replacing? And in the second part, it says, does the activity series ability to predict whether or not a reaction will occur agree with your observations? So let's take one of the solutions and let's say nothing happened. So I guess we could try to do. I'll hint. I'll do hints for the first one. Uh, silver nitrate. So we have aluminum here, and silver nitrate has the metal silver. So because aluminum is higher in this activity series than silver, does that positioning agree with the observations that we made of nothing happening? Does that make sense? Does it agree with copper? Does it agree with any of them? So question 4. What are the potential sources of error that might cause disagreement between the activity series and your observations? So this is something that's a little more, I guess, abstract would be the word. So are there any conditions that we're working with that prevents uh, the activity series prediction to be right? So one I can think of is um, the salt measurement that we made in the beginning. Maybe our measurements there weren't right, not allowing for the salt to make the reactions be more, well, reactive. So that's one to think about. Now, can you guys think of more? Or is there more? And question 5, write a balanced equation for the reaction between silver nitrate and aluminum. And what reaction is this? So we have silver nitrate and aluminum. So what is that reaction going to look like? And what kind of reaction is it? So I believe the lab last week, we actually went over this reaction, or or I mean, not the exact same one, but the kind it is. So if you have your notes from last week's lab, this should it should help out with this. Okay. Any questions so far? Okay, let's move on to the next part. So I'm gonna move this tinfoil out of the way first before we continue. Okay, let's start exercise 2. It says set a sheet of black paper or tablecloth and a sheet of white paper on the table. So I believe we did something similar 3 labs ago with the well plate. So we're going to be using it again. And again, we don't have these kinds of droppers, these pipette droppers with the solutions inside. We have the bottles. So we're going to have to just be careful again. And then let's see, set the second well 24 plate on a sheet of white paper and arrange the plate so that A1 well is in the upper left hand of the corner. So like in the image. And now we have to gather the chemicals sodium carbonate and hydrochloric acid. Okay, so it's sodium hydrogen carbonate. And hydrochloric acid. Okay, so let's observe the color of the solutions and then record our data on table 2. So let's see. So they're both clear and colorless solutions. And then I'm assuming observations, that's when we mix them together. Okay, so in A1, place 4 drops of sodium bicarbonate, and then add 4 drops of hydrochloric acid, then use a clean toothpick to stir and well mixed. Observe the interaction between the chemicals. It says use the white or black paper for backgrounds if necessary, and then record our observations. So let's do that. All right, so I'm pouring the bicarbonate into A1. Okay, I think that's 4 drops. I hope it's 4 drops. And then the hydrochloric acid. Okay. Made Sprite. Or well, Sprite's the first thing that came to mind. So I'm just gonna use a toothpick to mix them, even though there's a reaction did occur. Okay, something does happen when you mix them together. All right, observations. So still colorless, but it turned bubbly. And I would say yes. there is a chemical change going on here. All right. So moving on. It says, make sure you're using words that precisely describe what is being observed. Pay special attention to changes in color, odor, light, temperature, formation of solid, and formation of gas. So because it's bubbly, we can kind of assume that there's a gas formation going on. If you're doing odor, or if you're checking for odor, please be careful. Remember to stand around 6 to 8 inches away from the well plate when smelling it, because there's going to be a bunch of different solutions going on. And step 10, oops. From the observations, make a conclusion if there is a chemical change occurring. And we just did that. And then repeat the steps 4 to 10 for the remaining 7 reactions. Okay, cool. So we're gonna go ahead and move on to the second, which is iodine potassium iodide indicator and starch. So IKI and starch. So let's do that on A2. So I know in your chem boxes, your lab kits, there's like 3 different uh iodine potassium iodide indicators that came with it. We're gonna be using the one that's 0.1 molar. So the 1 mil. I believe it came in the chemical reactions bag itself. I don't mind it. So that's the one we're gonna be using. Because I believe the bigger uh the brown glass ones are different. So let's go ahead and do this first. So much like the 80% of solutions here, it's clear and colorless. As for the starch, shocker, clear and colorless. So let's put them together. So mine became slightly cloudy. I would put very slightly cloudy because you can barely make out the difference if you put it under white paper. That being said, I would say yes, chemical change. It says here the reactions in well B1 require 2 steps. So We'll get there when we get there. So now it's time to use potassium iodide. So this one, don't get it confused with the indicator. This one doesn't have an iodine in the beginning. It's just Ki. And wow, would you look at that? Clear and colorless. And now we're gonna use the lead 2 nitrate. Wowzers, clear and colorless. All right, so let's mix the two. This goes on A3, I believe. Well, something did happen. I'm kind of disappointed that we didn't get clear and colorless third time in a row. So it turned yellow. That's exciting, I guess. One thing that I noticed is that if I shine my flashlight on it, there's very tiny, I want to say solid formations. That's what it looks like to me. If it doesn't to you, then feel free to call it something else. So let's move on to the next one, which is sodium hydroxide and phenolphthalein. And they're back to clear and colorless. A true classic. Never goes out of style. Okay. Sodium hydroxide. E4. Darn. That's a good color. So there was color change. I don't know how to describe the color, so I'll just come back to that. But yes, there is chemical change. It looks almost like burgundy. So let's keep going. A5, hydrochloric acid, and phenolphthalein again. What do they look like? You guessed it. Damn. I put a little too much hydrochloric acid, but that's fine. I hope I don't have to use it again. Oh, yeah, we should be fine. And then phenolphthalein. Oops. Thank God I had a cap. Okay. Um, dirty. No. Cloudy. It's a lot more consistent than the A2 that we did. Let me use a toothpick. Yeah. After mixing the two, it's no longer clear. So solution became foggy. And I would say yes. I'm willing to change A2 to no, but we'll see. Maybe something happens. Sodium hydroxide and silver nitrate. Yep, we love consistency here. Okay, sodium hydroxide. And this is A6. Yeah, A6. That's wow. Ew. Kind of looks like Fireball's water. Brown. Some solid formation. It's not clear, so I'm hesitant to put foggy again. Not clear. There. Perfect. Okay, B1. That one has multiple steps, so let's read that. So the reaction in this well, B1, requires two steps. For B1, first step, combine 4 drops of each chemical and make the observation. Then absorb the chemical into a paper towel and expose the chemical soaked paper towel to bright sunlight for 30 minutes. And then come back in 30 minutes to make the second set of observations. That's great. If only the sun hit my room. So, it's partly cloudy here. So I don't think I'm gonna be able to get a reaction from the sun. So that's something you guys are gonna have to do. So we'll do the first part together. So silver nitrate and aqueous ammonia, or ammonium hydroxide, as it's labeled in the bottle. So B1, let's see here. Yeah, initial observations. As we've done it 3 clear and colorless in a row. So chemical change is gonna have to wait until sunlight's exposed. Oh, would you look at that? We're almost done. So we're gonna keep using the ammonium hydroxide, and we're gonna mix it with copper sulfate or copper 2 sulfate. So now that's that. We finally have a solution that's not boring, and it's blue. I barely have any copper 2 sulfate left, so that's gonna be fun. Gonna have to make it last. Okay, I barely have enough for the last one. So it's the darker blue. And cloudy. Cloudy slash not clear. So far, I haven't had to smell anything, or no like weird odors have appeared other than the vinegar from earlier. But I think that's because I just spilled it on my mouse pad. But let's move on. B3, and it's lead nitrate with calcium chloride. Wow, I barely have any lead left. Okay. Looks like it's the last time I'll use it though, so it's fine. Hey, something happened. So, yes, chemical interaction did go, or chemical change, I mean. All right, next one. B4, I forget. Sodium bisulfate, which I'm not seeing. Interesting. Okay, that's in the back. So sodium hydrogen sulfate is what it's called in the bottle, and calcium chloride. So, again, this goes on B4. And calcium chloride. Hmm. Another three in a row. So we're using the sodium bisulfate once again, and we're going to mix it with sodium carbonate. Lots of sodium. Wait, this is under B5. Oh, look, the return of Sprite. I'm not gonna write Sprite. So kind of similar to that first one. So it's still colorless. Um, gas was released, prompting to have a chemical change. So B6 is copper 2 sulfate and sodium bicarbonate. Yep. In the bottle, it's labeled sodium hydrogen carbonate. On the wrong one. This one's clear and colorless and boring. So B6. I think I just have just enough to have a reaction. Okay. A reaction occurred. So I'm gonna say yes. Um, I thought about changing my gloves, but I think I'll be fine. Famous last words. C1, blue dye. I wonder what color that is. And hydrochloric acid. So to distinguish it from the copper, I'm gonna say dark blue because it is darker, almost purple, and the classic clear and colorless. So C1. Cheers. Oh, nice. Color change. I'm not gonna say what color it changed to, but a color change did happen. Hey, C2, the last one. So we're finishing it off with sodium carbonate and phenolphthalein. Here it is. So we're finishing off with a bang of clear and colorless solutions. Wow, another color change. That's cool actually. Again, I'm not going to say the color change, what it is, because I want you guys to be also doing the lab and not just copying what I put. So I will say yes, there is a chemical change. So your data table should look a lot more filled out than mine. I'm gonna take off my gloves and replace them with new ones because I'm paranoid. So I believe the one for B1, um, it should be halfway done if it was 30 minutes. I forgot to check the time. But hopefully there is chemical change happening on that paper towel by now. So let's see. After all tests have been completed and the data recorded, thoroughly wash and rinse the plate. Properly dispose of used chemical pipettes according with local laws. We didn't have to use pipettes, so that's good. And return the equipment to the lab kit. Slow down for future use. So let's see. Question 1. What were the visual cues that chemical change occurred? Or chemical reactions occurred? So we did see a few of them on that first data. And there's also the obvious of color change. Okay. So those are probably two freebies. I think there is a third one. Question 2. Define a single displacement reaction and a double displacement reaction. Describe the similarities and differences between single displacement and double displacement. So within the reactions that we just did, which one of these is only switching partners once? Again, this is something that we covered last week on the lab, I think last week. If you're still unsure, we could just go back to modules and go to, well, it wasn't last week, it was 2 weeks ago, my bad. Lab 7. And it was in the second section of nomenclature. So in the well plate, when we're doing reactions, which one is undergoing a single displacement reaction and which one is undergoing a double displacement? And then once you figure out those, what are the differences and similarities of those two kinds of reactions? It says data. Okay, question 3. The data table 2 contains 9 double displacement reactions. So here it wants you to find 5 of them and write the balanced chemical equations for them. So it should look something similar to this one. The fourth example, or something similar to the 5 that you worked on here. Question 3. Oh, we just did 3. Question 4. Which reaction produces a precipitate? And then describe the observations when answering this question. So precipitate is also another word for solid. So look back at your well plate and then figure out which of them produced a solid formation. And then question 5, which ones produce a color change? And then describe the change in color for each of these reactions. For example, the reactions were clear and colorless, classic, and the product was bright pink. So we have about 7 color changes here. And then just write down which ones underwent that color change. And that should be simple. So yeah, I believe that's the lab. Quick reminder about the first section. Don't forget about the tinfoil. So remember at, I believe it was 4:38 is when you'll be able to fill out observations after 3 hours. And then once you rinse off that tinfoil, you'll be able to fill out the last section. And also for that second exercise, don't forget about the B1 reaction, this one. You should be coming close to 30 minutes by now. And as for the class itself, reminder, I believe you guys still have the exam available. So don't forget about that. Also, again, reminder on Thursday that the presentation sign up will be going up on Canvas. So discuss with your lab mates or group mates about which day you guys are willing to present. And that's it. That's the lab. That's all, folks.